Hi guys, this is Miss Regine from SOAR Educational Services, and we're going to continue working on these SAT problems. The last video got pretty long, so I like to keep them under 10 minutes. So let's continue with this. So in this problem, we are asked to solve for, the question says, what is y in terms of x? So I need to figure out what y is in terms of x. But as you can see here, I have x equals 3a, and then here I have y equals 9a squared. So different things, what they do have in common is that a, so I'm going to solve for a in the first equation. So we have minus 7, x minus 7 equals 3a, and then divide by 3. So now I have a equals x minus 7 over 3. So now that I have a equals x minus 7 over 3, I can plug it into where I see a here. I can substitute it to where I see a here. And I will have it in terms of x. So y equals 9, and I have x minus 7 over 3 to the second power. So what I would normally do is I would, FOIL and get x squared minus 7x plus 49. And then on the bottom, it would just be 3 to the second power, which is 9. Y equals, so on top I would have x squared minus 14x plus 49. It's minus 14x because I have to combine like terms here. And over 9. And then I can see that, the 9s can cancel out. So I have y equals x squared minus 14x plus 49. So this is how I would do it. Now looking at the answer choice, it was not expanded out like that. So it was like, so I kind of didn't need to do all that, but I could clearly see that, so then it was just this. Y equals x minus 7 to the second power. I didn't need to expand it out because in not expanding it out, I could still just leave it as x minus 7 to the second power. And then over 9. And I still had that 9 here. And then I could see that, they canceled out. All right, here's another one. Which of the following is a solution? Okay, so we have negative 2. We have absolute value here, and we're solving for x. So solve it like you would solve a normal equation. So you start with plus 5, so inverse operation, and that gives you positive 3. And I really just treat this absolute value just like I would if it was a parentheses there. So divide by 3, x plus 1 equals positive 1. Now this is where absolute value kind of deviates from regular problem. What you do is you set it equal to the positive and the negative value of it. So like this. So now you can do minus 1, x equals 0, minus 1, x equals negative 2. And on the answer choices, 0 is not there. So the answer choice was actually negative 2. And this is how the SAT will trick you to see, do you really know it? Because most people probably would know, let me just go through, I got x equals 0. But not remembering that this is an absolute value, so I need to also set it equal to the opposite. And then they would not find that 0 and just maybe be completely thrown off by it. So just something to keep in mind. All right, here's another one. So we have 3n minus 20. This one is not too challenging, I don't think. So you just have to solve for this. And again, you can pause the video if you think you're able to do this on your own. I probably would move the 3n over to this side to save time. And then I can divide by -2, divide by -2, and I get n equals 30. Okay, here, and this one is similar to another one that I did earlier, so definitely pause and see if you can solve it on your own. So yeah, we have fractions here, so we need to find a common denominator, which would be 15 in this case. So now here we can combine two values that are alike. So we have 11, 15x plus 120 equals x. And what we want to do here now is you want to move the 11, 15x to this side. So let's just do, we would do minus 11, 15x. So minus 11, 15x. We always have to have that common denominator. So this is 1x. So let me just change the color for this one. So to change it, we have 15 over 15. That way I have that common denominator, but I still maintain that value of 1. 15x minus 11x is 4x over 15 equals 120. And just like before, I can multiply by the reciprocal, and I get x equals 450. Okay. All right. On the SAT, there are some problems that you actually have to fill in. It's not multiple choice. So this next one is one of those types of problems. So if we have 6x squared minus 7x plus 2 equals 0. Now, I think now that you're able to use Desmos, a lot of students that I've been working with, I think they'll just plug this into Desmos and they have the solution. So if that works for you, great. I usually use this method called bottoms up. So I multiply the A terms times the C term, and then I factor. So, and then since I took out that 6, I need to bring it back in. So I divide by 6. I took out that 6 by multiplying by 6. So now I'm going to bring it back in. This can actually simplify. All right, and then final way is you take that denominator, move it up here. So you have 3x minus 2 and 2x minus 1. And your possible answers are actually x equals 2/3 or x equals 1/2. And you can put either of those answers in, and that would be correct. We'll try one last one. So in this problem, you have x squared minus 7x plus 12. And x squared minus 11x plus 24 equals 0. All right, and it says, what is the possible value of x? So with this one, what you need to do is this expression can be equal to 0, or this expression can be equal to 0. It could be either of them, and that's how you have an answer 0, because when you multiply, somehow you have 0. So one of these expressions would be equal to 0. So the best thing to do would be to factor your expressions out. And again, if Desmos work, and this is just like the last one we just did, but if Desmos work for you, by all means, you can try it. 8 and 3. So now that I have it factored out, my possible solution, you have x equals 4, x equals 3, x equals 8, and x equals 3. So they were asking just for one possible solution. So you could just pick one of these. You don't need to write the 3 twice or anything like that, but you just want, if x equals 4, that's going to cause one of these to equal 0. And setting the whole expression equal to 0. If x equals 3, same thing. You can plug it in. X equals 8. And if you're using decimals, you can try that and see if that's one of the roots where it hits the x-axis, then that would be why it's the expression is equal to 0. Well, I hope this was helpful. If you found this video helpful, please remember to like and subscribe, and I'll see you next time. Bye.